Okay, this is number 31, and A, B, and C. We just want to write these expressions as equations just in terms of x and y. They're parametric equations. They're in terms of a parameter t. So we want to eliminate the parameter. It's not too difficult. Okay, basically we use the first equation. The second equation, y is in terms of t, so I just have to get t in terms of x and then substitute, and that will eliminate the parameter. So I can take x equals to t plus 1, and then I can just subtract 1 from both sides, so t equals x minus 1. And then in the second equation, that's in terms of y, equals t squared minus t. Every time I see a t, I just put x minus 1. So I've got x minus 1 squared minus x minus 1. And basically that's what they wanted you to do. So we have an equation just in terms of x and y. Now if you look at your answer, it's not like this, so then you have to do a little bit more algebra to match it up to make sure that this is correct. So we can just square this binomial. We get x squared minus 2x plus 1 minus x plus 1, and then combine terms, and I got negative 2 and negative 1 is negative 3x, and 1 plus 1 is 2, and now that's the way they have it simplified in the answer section. So that's basically a little more algebra to get it to look the way they want it to look. Okay, let's take a look at the B part. And again, the y is the same. The y is, again, t squared minus t, so the x is a little more complicated. So again, I have to solve for t in terms of x, so I could add 1 to both sides, and then I could cube both sides, and t equals x plus 1 cubed. So again, over here, every time I see a t, I put x plus 1 cubed. So I got x plus 1 cubed squared minus x plus 1 cubed. Now I can multiply this out. I mean, I can raise this to the power. And remember, when we're raising exponents to powers, we just multiply the exponents. And I could get this. Or I can, if I look at my answer, now, again, basically this is done. This is the equation in terms of just x and y. The thing is that when you look at your answer, it's a little different, so you have to kind of doctor up what you have to make sure it is equal to the answer so you know you're along the right track. So you can either write it like this, or you can notice that I've got an x plus 1 cubed in both terms, so if I factor that out, it's going to look like more what they have for the answer because they had this x plus 1 cubed as a factor of the answer. So you factor that out, and you end up with x plus 1 cubed, one of these, because I took 1 out, and this is just 1. And now I have to multiply this out. Now remember, we had a special form for a binomial raised to the third power, and that was just going to be the first term cubed, and then we reduce 1 power, so that's going to be x squared, and this 1, and then we multiply it by 3, and this is kind of off of Pascal's triangle. But this was a special form that we kind of learned because we do the cubics a little bit more often than 4th, 5th, or 6th powers. And then we have also 3 times than just the first power, 3x, and then just the 1. So this x plus 1 cubed cubes out to be this. If you multiplied it out, x plus 1 times x plus 1 times x plus 1, this is what you get. But if you kind of remember this form, it's a little bit easier. So these 3's are the numbers that go here. And this is just x to the squared times 1, and then this is just x to the first power times 1 squared, which is 1. And this is 1 cubed, which is 1. Okay? It's kind of a form we learned. Now the 1's cancel. So I end up with this, and I have a common factor of x. So if I factor out that common factor of x, then basically I've got x, and I got x squared plus 3x plus 3, and I got the x plus 3 cubed. And this is the way the answer looked in the answer section, so you've matched that up. So that was a little bit of the work that you had to do. Okay? And the last part, x equals a sine of t and y equals a cosine of t. So we want to eliminate this parameter. So here's a little trick. This is one of the tricks we use when we have trigonometric parametric equations. If we could work it out, if we square both sides, we get x squared equals a sine squared of x. Y squared equals a cosine squared of x. And since this left side equals this right side, and this left side equals that right side, I can add the left sides, and the sum of the left sides will be equal to the sum of the right sides. And when I was a boy, we used to call this equals added to equals or equal. But here we're just adding the same quantity or equal quantities to each side. So since these are the same, I can add this to the left, I can add this to the right, and the equation will remain balanced. Okay, so I have x squared plus y squared equals sine squared t plus cosine squared t. Now what does this look like? This is our good old Pythagorean identity. This is equal to 1. So I end up with x squared plus y squared equals 1. Okay? And I've eliminated the parameter. And this is basically just a circle whose radius is 1. So that's how you would graph it if you had to graph it. Okay? So those shouldn't be too difficult. Parametric equations are kind of a BC topic, but you might have studied these a little bit in your pre-calculus class, so it shouldn't be too difficult. Hope that helps.